Have you ever wondered if there are seasons on other planets like there are on Earth? A fascinating question, isn't it? We humans are naturally curious creatures, always looking up at the stars and pondering the mysteries of the universe. And it's this curiosity that leads us to ask about the existence of seasons beyond our own planet in the vast expanse of our solar system. So are you ready to satisfy that curiosity? Well, buckle up, because we're about to take a journey through our solar system to find out. Before we venture off into space, it's important to understand how seasons work right here on Earth. The concept of seasons as we know them is a result of two primary factors: the tilt of the Earth's axis and the Earth's orbit around the Sun. Let's start with the tilt. The Earth doesn't stand upright. It leans on its axis at an angle of about 23.5 degrees. This tilt is what gives us our seasons. When the Earth orbits the Sun, this tilt means that different parts of the Earth receive different amounts of sunlight at different times of the year. In the middle of your country's summer, your part of Earth is tilted towards the Sun. This means that the Sun's rays hit your location more directly, leading to longer days, more sunlight, and consequently warmer temperatures. Conversely, in the middle of winter, your part of Earth is tilted away from the Sun, resulting in shorter days, less sunlight, and cooler temperatures. Spring and autumn, the transitional seasons, occur when the Earth isn't tilted towards or away from the Sun. During these times, the amount of daylight and darkness is roughly equal, leading to milder temperatures. But what about the Earth's orbit around the Sun? Contrary to popular belief, our seasons aren't caused by how close the Earth is to the Sun during its elliptical orbit. In fact, the Earth is closest to the Sun during the northern hemisphere's winter. It's the tilt of the Earth that really determines our seasons, not our distance from the Sun. The interplay between the tilt of the Earth and its orbit around the Sun creates the rhythm of life we know as seasons. This cycle of change not only affects our weather, but also influences our culture, agriculture, and even our moods. Now that we have a basic understanding of Earth's seasons, we can start exploring what happens on other planets. Our next stop is Mars, the red planet. Now, when we talk about seasons, Mars isn't so different from Earth. You see, just like our home planet, Mars also has a tilted axis. This tilt, combined with its orbit around the Sun, is what causes the Martian seasons. The tilt of Mars is about 25 degrees, which is very close to Earth's tilt of about 23.5 degrees. So just as on Earth, this tilt means that as Mars orbits the Sun, different parts of the planet receive varying amounts of sunlight at different times of the year. This variation in sunlight is what gives rise to seasons. But here's where things start to diverge. A Martian year is nearly twice as long as an Earth year, about 687 Earth days, to be precise. So while we have 4 seasons over the course of 365 days, Mars experiences the same 4 seasons over nearly double that time. Spring in the northern hemisphere of Mars is the longest season, lasting about 7 Earth months. Summer and fall are about 6 Earth months each, and winter is the shortest season, clocking in at just over 4 months. So even on Mars, you could experience a change of seasons, albeit a much longer one. From Mars, we travel to the gas giants, Jupiter and Saturn. These colossal planets are unlike anything we have in our own backyard. Dominated by swirling gases, they are a far cry from the rocky terrain of Mars or Earth. But don't let their gaseous nature fool you into thinking they don't experience seasons. They do, and boy, are they something. Jupiter and Saturn both have significant axial tilts, tipping at an angle of 3 and 27 degrees respectively. This tilt, much like the tilt of Earth, is what gives rise to the concept of seasons. But due to their slow orbital periods, these seasons last for several Earth years. Let's take a closer look at Jupiter first. With an orbit that takes nearly 12 Earth years to complete, each of Jupiter's seasons lasts around 3 Earth years. That's a long time to wait for the cherry blossoms to bloom, wouldn't you say? Now let's shift our gaze to Saturn. Saturn takes its sweet time around the Sun, completing an orbit in approximately 29.5 Earth years. This means each of Saturn's seasons lasts over 7 Earth years. Imagine having a 7-year-long summer vacation or enduring winter for 7 long years. But there's more to these gas giant seasons than just their duration. The drastic change in sunlight during the different seasons causes dramatic changes in their atmospheres, leading to fascinating phenomena like the vibrant color changes in Saturn's clouds, or the increase in Jupiter's storm activity. These extreme and prolonged seasons on Jupiter and Saturn are a testament to the diverse and dynamic nature of our solar system. They remind us that even on planets where no life as we know it could exist, the dance of celestial bodies around the sun continues to create a rhythmic and ever-changing spectacle. So if you thought winters were long on Earth, imagine living on Jupiter or Saturn. Our final stop is the ice giants, Uranus and Neptune. These distant neighbors of ours have a unique way of experiencing seasons, largely due to their distinctive axial tilts. Let's start with Uranus. This blue-green beauty is tilted at an extreme angle, almost onto its side, a staggering 98 degrees to be precise. This peculiar tilt results in each pole getting a continuous dose of sunlight or darkness for about 42 Earth years. Yes, you heard it right, 42 years of continuous daylight or an equally long, chilly night. Imagine having a summer vacation that lasts for decades. This unusual orientation of Uranus also leads to some very extreme seasonal changes. When the sun shines directly over one of the poles, the other pole is plunged into a deep, cold winter. Conversely, when it's summer at one pole, the opposite pole experiences a long, dark winter. This results in dramatic temperature variations across the planet, leading to some of the most extreme weather in the solar system. Now, let's shift our gaze to Neptune, the farthest planet from the sun in our solar system. Unlike its sibling Uranus, Neptune has a milder axial tilt similar to Earth's. This causes its seasons to be less extreme. However, don't be fooled into thinking Neptune has a calm weather system. Its seasons, though less dramatic, still produce the strongest winds in the solar system, reaching speeds of up to 1,200 miles per hour. In comparison to Uranus's long, drawn-out seasons, Neptune's are shorter, lasting about 40 Earth years. While this might still seem incredibly long to us, it's pretty standard for these distant, slow-moving planets. So the next time you complain about the weather, remember, it could be a lot more extreme. So, there you have it. We've taken a grand tour across our solar system to understand how seasons work on different planets. We've learned that, much like on Earth, the tilt of a planet's axis and its orbit around the sun are the primary factors that give rise to seasons. On Mars, with its similar tilt and elliptical orbit, we see familiar seasonal patterns, though they last nearly twice as long as ours. Then we ventured to the gas giants, where the immense size and rapid rotation make for short, extreme seasons. We discovered that Uranus, with its unique sideways tilt, experiences decades-long seasons, while Neptune's extreme distance from the sun results in subtle seasonal changes. Remember, no matter where you are in the universe, the concept of seasons is a universal one. So keep exploring and keep learning, because the universe is full of wonders waiting to be discovered.